Alright guys, here's part 2. We're starting at question 38 on chapter 4. Is this relationship a function y or y not? We remember for every x there's only one y. So for every x, only one y value. So I see 1, 2, 3, 4. So all the x's are different numbers, so it really doesn't matter. So we say yes, function. The next one, we have 10, 7, 10, and 9. We have 10 twice, so for every x there's only one y. 10 has two different y values, 8 and 3, so no, not a function. Okay? F of x equals 3x plus 12. F of negative 1 means we're going to plug in negative 1 for x. Again, whenever we plug in, we use the parentheses. That's going to become negative 3 plus 12. And so we subtract that, and we get 9 as our answer. Find the domain and range of the function presented here. The range is going to be pretty easy to find. It's going to start out here, and then it's going to go up, but then it goes up forever. Okay? So our range and our domain, again, range is the y values, domain is the x values. And to write this in interval notation, we would say we're going to include negative 2, but we're going to go all the way to infinity and have an open bracket. Now the domain, as this is going outward, it's going to go on infinitely outward. So it's actually going to cover every single x value. So for the domain, we can just write infinity or all real numbers, meaning it could be any real number. Number 42 is a little bit easier actually because it has specific constraints to it, unlike the other one above. And to find our range, it's going to go from negative 2 up to 5. So bracket that, negative 2 up to 5. And the x value is going to go from negative 4 all the way up to positive 3. Negative 4 to positive 3. Okay, without graphing, tell whether the point is on the graph. Remember, f of x is also known as y. So we can actually just plug these 2 points in, x comma y. So that means 9 would equal negative 2 times 2 minus 5. And negative 2 times 2 is going to be negative 4 minus 5, which is negative 9. 9 does not equal negative 9, so not on graph. Okay, these did not equal each other. If they did, then we would say it's on the graph. Write the equation in slope-intercept form. So slope-intercept form is y equals mx plus b. It means I just need to solve for y. Subtract 2x on both sides. And get y equals negative 2x plus 5. Again, same thing. We're going to subtract the 9. Now the problem here is I have a negative, so I got to actually multiply basically everything by negative 1 or divide by negative 1. It will basically just change the sign of everything inside, which makes my y positive, which makes me happy. Okay? And again, slope-intercept form, I'm going to subtract the 3x. And then I'm going to divide all pieces by 5. That 5 will cancel here. That's going to become negative 3/5 x plus 7/5. And I can leave it as fractions there. That's more than fine. Okay, find the slope between 2 points. We're going to use what's called the slope formula. y2 minus y1 over x2 minus x1. And we'll just plug those in. Okay, so we're going to get 0 minus 3 over negative 3 minus 3. That's going to become negative 3 over negative 6. That becomes 2 negatives, make it a positive, and that reduces to 1/2. Again, same thing, x1, y1, x2, y2. I have the slope formula written up here, so I'm going to utilize that again. Notice there's a negative built in the equation, and x1 is also negative, so it looks like there's 2 negatives next to each other, which is going to make them positive. 5 minus 3 is a negative 2, and then that's going to add to be there, and that is the final answer. I can't reduce much further than that. Okay. Just to make sure you're getting practice, huh? Right? Practice with our slopes. We got a couple more. X1, Y1, X2, Y2. Negative 4 minus 4, and 4 minus 2. That's negative 8 over 2, which is negative 4. I'm going to go a little bit faster on these ones. 2 minus a negative 2 over negative 2 minus 1. Negative and negative make it positive, and that's negative 3. Find the slope and y-intercept. To do that, I put this in slope-intercept form. So I'm going to subtract the 12x. So 4y equals negative 12x plus 2. And divide everything by 4. So y is going to equal negative 3x. 12 divided by 4 is negative 3. Plus 1/2. So my slope is going to be negative 3 over 1. And my y-intercept is going to be 1/2. Again, m is going to stand for slope, and b in the equation stands for y-intercept. Okay, find the x and y-intercept. This is where we can do the cover-up method to find the y-intercept. We are going to just do negative 6y equals negative 18. And to find the x-intercept, we're going to cover that piece up and get positive 2x equals negative 18. You can solve each of those. Divide by negative 6, y is going to equal 3. And divide by 2, x is going to equal negative 9. It's kind of like the fast way to do that. Same thing we're going to do here. I already have the column set up, so that's going to be negative 9y equals 72, and 6x equals 72. So we're just going to divide 72 by negative 9, and we're going to get y equals negative 8. And over here, it's 72 divided by 6, and we're going to get x equals 12. And one last time. Now, I'm going to have to move this over first, so I'm going to get 3y plus 6x equals 3. And now I can go ahead and set that up as 6x equals 3, and 3y equals 3. I kind of flip-flop that, sorry, so those are kind of in my columns different. But this would divide and make me have 1/2, and this would equal 1. Find the x and y intercepts, then use them to graph. So again, we can do the same thing. Get a lot of practice on a lot of similar traits here. Divide, we're going to get x equals negative 6. So we're going to go negative 6, put a point. Divide by 3, and y is going to equal, what is that, 8, I believe. I'm going to double check. 8. I was just wondering because it's kind of off the graph. And boom. That's how you graphing the y-intercept and the x-intercept. Write the equation of a horizontal line that passes through the point 2, 5. Remember, a horizontal line has a slope of 0. So we're going to put this into y equals y equals, let me say that one more time. Y minus y1 equals mx minus x1 point slope form. Here's my point x1, y1, and we're going to get y minus 5 equals 0, and x minus 2. Now this is all going to go to 0 anyway, so I'm just going to get y minus 5 equals 0, add the 5 over, y equals 5. With the slope of negative 4, with a y-intercept at negative 3, this is really easy. We can put this into y equals mx plus b form, and the reason why is because I have the slope and I have the y-intercept. Here's my slope, and my y-intercept's at negative 3. That one's a little bit easier. Write the equation of a line with an undefined slope that passes through negative 3, 4. Okay. Now, undefined slope means there is no slope. It's going to be an x value. So instead of plugging this one in, the easier thing to do is just kind of graph it real quick. and go 1, 2, 3, 1, 2, 3, 4. Here's the point, and so the line's going to be going up and down. So it hits the x-axis and it hits it at -3. So that's where the line's going to be. That'd be the fastest way to do that one. Write the equation line with slope equal to -3 passes through the point 2, 1. So we can do a very similar thing we did before. So our slope is -3. And then we're going to plug in our point right here. Y minus 1, x minus 2. And we're going to distribute -3x plus 6. Add the 1 over, and y is going to equal -3x plus 7. Write the equation line with slope 2 passes through the point -3, -3. I already have the equation written up here, so I'm just going to plug in. Notice I put in positive 3's because the equation has negatives built in, but since these were both negative, it's actually going to come out positive. And I'm going to subtract the 3, and y equals 2x plus 3. Okay, now we're writing the equation of the line through 2 points, which means I need to go ahead and utilize the slope formula. Label my points, and then we can plug in -3 minus 3. And 4 minus 5. So my slope is 6, and then I can use a point and a slope to solve. I got the 5 and the 3 from using x1, y1. I could have used this point, but I already labeled it x1, y1, so I'm just going to use that. Distribute. Add the 3. Y equals 6x minus 27. We're going to do the same thing again. I'm not going to use write the formulas because I already have the formulas written out right there and right there. But I will label my points. Always a safe thing to do. Whenever you have two negatives next to each other, they do have to become positive. And I got -1 over 9 as my slope. And we're going to plug in. Now my x and y were both negative, so the equation actually looked positive. Subtract the 5. So here we have two negatives. That's actually going to become -5 and 2/9. Okay, or I could do 5 times 9, which would be 45, and I could get 47 over 9. So either one of those two would be fine. Right equation of a line that's parallel passes through. Remember, parallel, we have the same slope. Okay, so I'm just going to steal this slope of -3 and write it into my equation. Okay, and 3. So our slope is the same as the other line because they're parallel. And then we plug in our point as x1, y1. And we can go ahead and distribute. And add the 3. Y equals -3x plus 18. Same slope, different y-intercept, so they are parallel. Write the equation line that's perpendicular. Perpendicular is going to have an opposite reciprocal. So it's going to have negative 1/2 slope that we're going to use, and passes through this point. Now I have the equation written right here, so I'm just going to plug into that. Y minus 6 equals negative 1/2 x plus 4. Distribute. And then we distributed half of 4 is 2, becomes negative. Subtract the 6, add the 6 over, you get 4. Alright, the equation of the line shown below in slope-intercept form. Okay, well this is pretty easy. We can first find the slope. I can find it by counting. I'm going to go rise over run, 1, 2, 3 over 1. Okay, so the slope is rise 3, run 1, and the y-intercept is 2. So we just get y equals 3x plus 2. Equation of the line here, I'm going to find the slope. I'm going to go down 1, 2, 3 over 2. So slope, down 3 over 2. Y-intercept is at 1. Graph. To start, we graph at the y-intercept of 1, and then we use our slope. I'm going to go down 1, 2, 3 over 1, 2, 3, 4. We can do it backwards. Instead of going down 3, I can go up 1, 2, 3. But instead of right 4, I can go back 1, 2, 3, 4. Our slope is negative in our picture, and our slope is negative in our problem. To graph x equals negative 4, go to negative 4, and it can only hit the x-axis, so it's got to go up and down. Y equals 2, go to y equals 2, can only hit one axis, so it's got to go left and right. This one we can graph using x-intercepts, so that's going to be 3y, so y equals 1, and x will equal 3. So I can plot those points, and just draw a line through them. Okay, 71 through 80. Test scores. Okay, for the mean, we got to find the sum and divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I'm going to do that real quick. So I got 797 divided by 10. That's going to be 79.7 is the mean. The median, it's already in order, so we can just count in. 1, 2, 3, 4, and 5. So these two are in the middle, so to find the middle, we're going to have to add them together and divide by 2. Or what's right in between them? 87. The mode would be 65. It was the most common test score. The range is going to be from 100 to 36, which is 64. The quartiles, okay, so lower quartile is going to be found within this range, and that's going to be 65. And the upper quartile is going to be found in this range, which is going to be 96. What is the interquartile range? That's going to be from Q1 to Q3. So we're going to go from 90, well, the better way to write that would be Q3 minus Q1. So that's 96 minus 65. What is that, 31, I think? Find the maximum value, 100. Minimum value, 36. Construct a box and whisker plot. Okay, so I have to go basically from 36 to 100 here. I'm going to count by 5s. Starting at 30, 40, 50, 60, 70, 80, 90, and 100. Probably could have counted by a little bit more, but there we are. 36 is right about here. 100 is up here. Our first quartile is at 65. Our third quartile is at 96, and our median's about 80. Okay, 25% of our data is here, 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 and here. Okay, what's the range of class 1? Class 1 is going to be 95 minus 30, which is 65. The median of class 2 is going to be at 75 right there. What percent of the data for class 2 is greater than 65? So 65 or greater is going to be 25 plus 25 plus 25. That's 75%. What was the lowest value for class 1? I'm going to say it's their minimum value of 30. Find the standard deviation of the data. So we can put our, first thing we have to do is find our mean. 1 second. Okay, I just calculated the mean real quick. So we're going to go ahead and find the difference between the value and the mean. So 13 minus 15 is going to be negative 2. Negative 2 squared is going to be 4. 14 minus 15 is going to be negative 1. Negative 1 squared is going to be not 4, but 1. 15 and 15, that one's going to result in 0, 0, 0, 0. And then 15 minus 6, the other way. 16 minus 15 is going to be 1. 1 squared is still 1. And 17 minus 15 is 2. 2 squared is 4. And the sum of those is going to be 10 divided by the total number, which is 10. And we get 1. And the standard, that's the variance, and then we have to take the square root of 1. So our standard deviation is going to be the square root of 1, which is just 1. Use the table below, answer the following questions. We're almost done. How many people prefer football? 65 total people prefer football. What's the joint relative frequency of women who prefer football? So we're going to look at women who prefer football out of the total number of women, because we're looking only at the women. So 28 out of 80, and we could find the percent, which would be 75%. What's the marginal relative frequency of people who prefer basketball? So people who prefer basketball is going to be 36 out of the total, which is 160. And we're going to get 22.5%. Okay, use the dot plot to answer the following questions. How many students were surveyed? We just have to count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. How many students ran faster than 10.4? So everyone over here, 1, 2, 3, 4, 5, 6. Or wait, that's slower. I apologize. We want to go faster. So 1, 2, 3, 4, 5, 6, 7, 8. What percentage of students ran 10.3? Well, we have 4 of them out of 20. And so we're going to divide that. And we get 0.2, which is 20%. And last question is, the table draws scatter plot to determine if a relationship exists. So distance and time. Time's usually on the bottom, so we're going to do 1, 2, 3, 4. And then it looks like we're going from 50 to 180. 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 180. We go a little bit higher. 1 and 50, 2 and 85, 2.5 and 120, 4 and 180. I would say that there is a positive relationship between these two. That's all.